Hello there, everybody. My name's Phil Lamar, and I want to welcome you to NASA's Ask the Astronomers Live, where we have live astronomers, not robots or holograms, here to answer your questions about the universe. Now, you can put your questions for our scientists in the comments section of the stream of whichever platform you're watching it on. And if you want to find out about any upcoming shows like ours or other shows, or just see lots of fun astronomy videos, go to the Universe Unplugged website, right there, universeunplugged.org. And when you ask a question, please try to include your social media handle. That way we know it's not just coming out of the ether. All right, today we are talking to two brilliant astronomers who have been studying brown dwarfs. Let's say hello to Dr. Davy Kirkpatrick and Dr. Jackie Faherty. Davy, you are from NASA's IPAC Center over at Caltech in Los Angeles, correct?
That's correct.
Why don't you tell us, tell the audience a little bit about yourself and what you're working on these days.
Well, I've been working my entire career on low mass stars and brown dwarfs as research. And I've been finding those very interesting for quite a long time. And as part of my other day job, I actually work on quality assurance for images and data coming out of some of NASA's infrared missions.
Oh, excellent. And Jackie, thank you for being here.
Hi, yes.
And
hi, Davey.
You work at the American Museum of Natural History, right?
I do. Correct.
And you know Davy.
I do know Davy. Davy is actually my academic grandfather, which I'm not sure he loves me saying grandfather, but
okay.
Davy was the advisor of my advisor in grad school. And so we're academically related to each other, not actually genetically in any way, shape, or form. It's only that, we're related academically.
Academic grand. Yes. What would be the grand of Godfather?
Oh,
Godfather? No, I don't know.
I don't know that we have that. I mean, people do talk about cousins and like distant relatives. People will trace their academic heritage all the way back as far as they can get in, famous PhDs. You can go back 200 years and see well you're related to like Eddington or Einstein or something like that.
That's six degrees of Isaac Newton. I don't know.
Yeah.
Wow. All right. Our topic today is brown dwarfs, which not for anybody who gets confused and thinks that they've suddenly gone off onto some D&D Twitch stream. No, we're still talking astronomy. Davey, could you please tell the audience and me what brown dwarfs are?
Yes, so if we could have video number 2, please. So brown dwarfs are objects that form like stars do. So if you look at a cloud of collapsing gas, for example, and this is a prediction shown here, and we've got the time in the upper right-hand corner just ticking off about 1,000 years per second. You see that as this cloud of gas collapses under its own gravity, you get these concentrations shown by the yellow dots. And if these concentrations get hot enough in the interiors, they will start to form huge hydrogen into heavier elements. And those are things like stars like the sun, that will burn for billions of years under their own light or under their own energy. So they actually are seen at the same temperature and at the same luminosity for billions of years. But there are some objects, and there are some other objects in this prediction here that are also little yellow dots, but they don't quite get enough mass and they don't get hot enough in their interior to actually start fusing hydrogen into heavier elements. So they don't have that internal energy source that will keep them burning for billions of years. And those are the brown dwarfs. And we think brown dwarfs form roughly around 72 Jupiter masses or lower, and everything above that in mass, above 72 Jupiter masses, is a star. And I will point out that for the savvy listeners out there, there's another set of definitions that is used sometimes for brown dwarfs. and that is a mass-based definition where they say brown dwarfs are things between 72 Jupiter masses and 13 Jupiter masses, and anything below 13 Jupiter masses is called an exoplanet. But Jackie and I decided for this particular show we would use the older definition, which is the one based on formation.
Interesting. So, okay, so brown dwarfs are these gigantic, not quite stars.
Correct.
So it's like if you're a big developer and I built this amazing building and I want all of these people to move into it, and no one ever does. It's like the shopping center that's empty down the block.
I want to say, I'm going to say the definition that I very much dislike, or the description of brown dwarfs that I very much dislike, because I feel like it should actually be said and then refuted. And that is that brown dwarfs are failed stars. And there's conference proceedings. There's books that were written where people were trying to like figure out these objects, and the titles are failed stars and their properties. But I really dislike the word failure in anything. So even though in some, and that also implies that they had some preference to be, I have a little mass companion under the room. Sorry about that. This idea that these objects that they should be stars, you know what I'm saying? Like there's nothing about them that says they should be anything. They're very good at what they are. And what they are objects that are existing in space. and they're good for what they are. Okay, then. Right.
Like if one of the Jonas brothers wants to be a doctor, he is not a failed Jonas brother.
Good analogy for pop culture. You shouldn't assume that everything should be a star. So sometimes I will call them overexcited planets because people love the word planet more. But really, I don't know that I even agree with that, right? Because that just means that the planet is the thing to be. I think they should be good with what they are. They are brown dwarfs. That is what they are. Excellent. And we love them for what they are.
And you guys work on analyzing brown dwarfs or discovering them? I mean, are they hard to find?
Yeah. So I can answer this one. Is Davey and I Davey should say something to this too, because Davey was around for all of the early day searches. And so what happened was we kind of were figuring out stars through the early 1900s. Right. And then we get to the point where we're trying to figure out what's the lowest mass thing that fragments off and it still basically forms like a star. So what's that lowest mass thing? And what we came upon was this idea that I bet you can get to the point where you break off, and like Davey says, you can get to 75 Jupiter masses, and at that, or 72 Jupiter masses, you get to the point where the object starts to look a little different. But the thing is, it's really cold. So it's giving off the majority of its light in comparison to stars. It's giving off the majority of its light at a wavelength that our eyes can't detect. Or at least our eyes are not sensitive to at all. So they give off the majority of their light in the infrared. So you kind of had to wait until infrared technology was really ramped up in order to start finding these. And that's basically where Davey comes in as one of the first true brown dwarf hunters or brown dwarf discoverers in large bulk.
Was the infrared technology just burgeoning when you began doing this work, Davey?
Yes, really. In fact, the earliest infrared detectors that we had back when I was in grad school were 1 pixel by 1 pixel, so essentially 1 pixel array. And it was really hard to get very much of the sky mapped when you have 1 pixel. You can imagine having a digital camera these days with a single pixel in it. It would take you forever to take a portrait of somebody. So we had to wait for the technology to actually give us large enough arrays to actually tile the sky.
And where does the name brown dwarf come from? Does it come from the fact that they are so cold that they're not giving off red heat?
Well, it was really back in the day when they were trying to figure out what to call these objects. People were saying, well, they cool down steadily with time, so they're kind of red. They're mostly infrared type objects. But they'll eventually go black. But the problem was that red dwarfs was already a term that was used for M-dwarf stars. And black dwarfs are the end products of white dwarf evolution. When they go completely cold, they will be black dwarfs. So Jill Tarter, who's a scientist at the SETI Institute, came up with the idea of let's call them a color that's not really a color and just call them brown, because we really don't know what they're supposed to look like.
Right.
So brown dwarfs just stuck as the term.
Interesting. So brown dwarf was in relation to all the other color designations that already existed at the time.
Right.
Wow, this is fascinating that this is a relatively new arm of astronomy.
Mm-hmm.
And you're saying that now you have the infrared technology. You're not looking at one pixel at a time. You have wide arrays of the galaxy to look for brown dwarfs.
That's correct, yes. And in fact, we have some of these capabilities now on a spacecraft. So up above the Earth's atmosphere, we can get to the wavelengths that we can't reach from the ground because of our atmosphere absorbing that light. And in fact, as Jackie was saying, out in the infrared, where most of these objects have their peak flux, that happens to be an area that we can't really observe very well from the ground because of the Earth's atmosphere. So not only do we have to develop these infrared arrays in a large format, we had to get them up out of the atmosphere as well. So that's where spacecraft like the WISE mission, the Wide Infrared Field Survey, came into power.
And one thing I want to note on this too, because sometimes I get asked this question where people get excited. They're like, "Ooh, brown dwarfs! Can I go outside and see one?" And I have to say, no, not even the closest brown dwarfs, not even the ones that are basically spitting distance away from you. You can't actually see them with your eye because they're too faint. They're literally invisible to you. So unless you have infrared eyes, you're not going to be able to see these kinds of objects. You need telescopes, you need nice detectors in the infrared, and then we can start seeing them. So we can tell you that they're all over the sky, but we don't have any. I can't tell you where to look because you can't see them with your eye.
Okay, so I would imagine working with things that are invisible, that of course makes them difficult to find. Are there other difficulties in terms of the work you guys are doing in terms of identifying, finding in the sky?
Yeah, I'll mention that part of why I think we're excited to talk to you today too is because Davey and I are a part of this project. It's called Backyard Worlds: Planet 9, and this is a citizen science project, which means it's open for anyone and everyone that wants to get their toe in the pool of scientific research to come on and help us locate brown dwarfs. Now, because like I said, you can't see them with your eye. We need to look through images from telescopes. And then there's like other tricky things about this. So astronomers have been working on the issue or the search for brown dwarfs for many years now. But one of the ways that we can find them is if we look through images that are taken with enough time between them, that we'll actually see the brown dwarfs move. And the reason for that is that objects that are closer to you, objects that are closer to the Earth, to the sun, to our solar system, will actually be able to detect their motion through the galaxy if we wait a couple of years. Sometimes you don't even have to wait a couple of years. And so you can blink between images. It's actually the way that Pluto was discovered in our solar system. It didn't need to wait years for images between Pluto. You could wait days in between and see an object jump around in our solar system. But we look through images, loads and loads of images, infrared images, and we ask citizens to help us detect objects that are bright in the infrared and that jump. And so actually we have a video for this. If you pull up, video 1, this is actually something amazing. I'll say the software that generated this, or the viewer that generated this, was actually developed by someone named Dan Castleton, who's a citizen scientist that works with us. And what it's doing is it's taking several images over, I think, like a 7 or 8 year period here. And what you're seeing is most of the black dots in this don't move at all. Those are stars that are so far away that we cannot detect their motion in the galaxy. But if you notice at the center of this blinking image here, there's a black star that moves back and forth and that orange dot that also jumps with it. And this is a little family that we discovered, that actually some citizen scientists discovered, of that black object, which is barely a star. It's almost a brown dwarf, actually. And that orange blip that's jumping back and forth, that is a low temperature, cold, low mass brown dwarf that is very close by to the solar system. And it was discovered by citizen scientists. We followed it up and we actually wrote a paper about this. So we've been using the eyeballs of citizen scientists to help us look through thousands and thousands, actually at this point, probably almost millions of images of the sky to find more of these objects.
That's amazing. So Davey, other than what Jackie just showed us, what else has the crowd helped you find?
Well, lots of interesting brown dwarf candidates that we've been following up at various telescopes across the world, as well as other things too, like white dwarf stars, which are the remnants of actual stars that have gone poof in the night. They've expanded all of their thermonuclear fusion in the core and have turned into stellar remnants. But they found lots of other interesting things too, like brown dwarfs that don't fit with our idea of what brown dwarfs should really look like as well. So we found some things that are not exactly what we expected based on the theory that these objects should look like. And again, she just mentioned Dan Castleton, who built the WiseView viewer, but he found something that we've been terming the accident. And the accident is an object that moves across the sky, just like as Jackie was showing in that little movie. It's clearly got proper motion compared to the background stars. And proper motion just means that if you've got a very close object, you can see it moving relative to the background stars that are relatively still in space because they are so far away. And he found this by accident. He was looking at something else and noticed in the corner of the image there was this other object moving. He's like, oh, wait a minute, if that's moving, it's got to be pretty close, right? But it didn't have this orange color like the object that Jackie showed. So not only are the citizen scientists finding things like brown dwarfs and white dwarfs and other objects we already know about, but they're finding some things that are not like anything we expected.
Interesting. So that might change what Jackie's scientific grandkids study.
That's a good callback. It's very true. That might very well be changing the face of brown dwarf science, but they would also be Davy's great grandkids or whatever. It's all in the family.
I'm beginning not to like this.
That's funny. Well, now, Jackie, in the video you were showing us the brown dwarf that was closer to us in relation to the. What does this new information that we're getting tell us about our neighborhood of the galaxy?
Yeah, so Davy is going to talk about this too, but I want to use a video. So if we could turn video 3 on. This is actually a video that I rendered using some software called OpenSpace, which is a visualization tool that we're developing in part at the American Museum of Natural History. And that's the Earth. We're pulling away. I've turned on all of the constellations for you, all 88 of them. So you can see the zodiac constellation of Leo, which is actually red because it's a zodiac constellation. And all of those red objects are brown dwarfs. Now we're pulling away. We were close to the solar system and now we've pulled away. All of the lines have now kind of separated off because those are the lines connecting constellations. We're out here now with this grid, which takes us out to like 100 light years or so away from the Earth. And that map that you're seeing of all those red objects there, and this grid, this 100 light year grid, is for scale for you with stars that are there's the stars are also in here, so you see them as white. Those objects have all been mapped and are telling us something about the locations of the lowest mass objects of star formation. what we call the basement of star formation. And what we've been doing is trying to take all this information of objects that may have been missed by astronomers' surveys that were garnered from participation from citizen scientists, and counting them all up and seeing in just this view as we come in on the Earth with this like realistic view of what the Earth might have looked like on whatever day I rendered this video. That would be your nighttime sky view. If you could have brown dwarfs in it, because you could see them, that would be in part your view.
Interesting. Now, Davey, I noticed when you were talking about the definition of brown dwarfs, you were talking about Jupiter mass. How do brown dwarfs compare to the large planets in our solar system like Jupiter?
Well, I think this is going to surprise you, Phil. If we could see image number 3. So we talked about brown dwarfs having masses anywhere from 72 Jupiter masses down to a Jupiter mass or even lower. But a funny quirk of physics, and these are all to the same scale here. This is an artist's rendition by Robert Hurt from IPAC. On the far left, we have an image of the sun to scale. And the 4 objects that are shown to the right of it are an M dwarf star, a couple of brown dwarfs that are various temperatures, one a little bit warmer than the other, that one's redder, and then we got the purple brown dwarf next to it, and then the planet Jupiter. Well, these are all to the same scale. It turns out that low mass stars, brown dwarfs, and the planet Jupiter all have essentially the same size. But the weird thing is that these masses are vastly different. The low mass star, the one next to the sun there, could have a mass as high as, say, 100 or 90 Jupiter masses, something like that. The red brown dwarf next to it might be 70 Jupiter masses. The one next to it, the purple one, could be 30 Jupiter masses. And of course, Jupiter itself is only 1 Jupiter mass. So it's kind of, one of the reasons these things are so hard to find is that, you know, not only are they faint, but they're faint primarily because they're tiny.
Interesting. Okay, so yes, okay. Because initially when you said 72 Jupiter masses, I guess I just sort of overlooked the word mass and was thinking volume. But no, it's so the volume can vary, but the volume can be relatively the same, but the mass varies widely. That's amazing.
Right.
Oh, wait, we're sort of the halfway mark. So let me just say, for anybody who missed the beginning of the show, or if you're just joining us in the last minute or so, we are chatting with Jackie Faherty and Davey Kirkpatrick about the latest results about brown dwarfs in the neighborhood of our sun. Now, let's see if we have any audience questions. Yes, here we go. This is for both of you to answer, because we want to know your origin story. What is it that got you interested in studying brown dwarfs? I guess we'll go chronologically. Davey, you go first.
Start with Grandpa, yeah. Well, when I was in grad school, and even when I was an undergraduate, I started hearing stories about the nemesis hypothesis. And the nemesis hypothesis was trying to explain the fact that it appeared that these mass extinctions on the Earth happen cyclically, meaning that every 26 million years there was another mass extinction event where plants and animals just died off in giant numbers. And there was this issue of, I believe it was Science Magazine, where they had a bunch of people come in and say, write papers about what could possibly explain this. And the one that really caught my eye was the one where they said, well, maybe the sun has a stellar companion in this very long elliptical orbit that only takes it into the into the solar system environs about every 26 million years. And it upsets the Oort cloud. And the Oort cloud is a primordial area of the solar system way in the outskirts where all these ancient comets live. And if this star is pummeling through that area of space, it can send comets into the inner solar system. And those comets can pummel the Earth and, do all kinds of havoc to plants and animals on the surface, of course.
Wow.
Well, the thing that really struck me about that was the sun could have a companion, a star we don't know about. What? This is crazy. And, the astronomers didn't run around and throw their hands up and say, oh, this is crazy too. They're like, yeah, could be. I'm like, wow. Here it is 1980 something, and we don't know if the star is a double star. I mean, our sun is a double star or not. That struck me as just incredible. So I got interested in what other discovery space there might be out there, and that's when I started learning about these theoretical entities called brown dwarfs, which were thought to be an end product of star formation that could be very faint and very cold. And I said, that's what I want to study. I kind of like that idea. Let's go after the brown dwarfs and see if they actually exist.
Wow. Okay, that makes sense. And I'm pretty sure somewhere Ridley Scott is working on a movie called Nemesis Hypothesis.
I don't know how that movie hasn't been made.
Right?
It should have been made by now.
Totally.
It better be scientifically accurate when they do make it. It would be very upsetting if it wasn't.
Well, if they wait 20 years, maybe the science will change. But in the meantime, let's go back in time and find out, Jackie, what got you interested in studying brown dwarfs?
Yeah, well, actually, Grandpa Kirkpatrick here is one of the reasons why I chose brown dwarfs. And that is one of the little known, the lesser known things about science is that you can choose anything in the universe to study. There's mysteries about everything. There's mysteries about Earth that we live on, that we can walk around and study and, pick up rocks and learn about them. But so everything is open to you when you start graduate school. And I'm sure you can get excited about everything because everything's got some good stuff about it. But there's also this other aspect, which is the people. Whichever subfield you choose of science, you're probably going to be within that subfield or closely related to it, whatever it is that you've chosen as your object or area of study for years of your career. And when I showed up in brown dwarf science, or when I showed up in graduate school, brown dwarfs were very young still, in the sense that they'd only sort of just been, we've only just started studying them observationally. So there was a lot that one could do. And the people that were there, like Davy, were awesome. They were really nice. And it didn't feel like super cutthroat and competitive. It felt welcoming. And I loved the idea of entering a new field meaning these objects were kind of new to our plethora of objects that we were studying. And the people that I want to spend my time with, like you can ask Davey, we spend a lot of time together in meetings right now. So I think I picked the right choice, that they're the people I do enjoy being around. So from that sense, this was the choice made so that my days were very nice from all of the objects we were studying, but also the people I get to spend them with are pleasant. There
you go. Yes, your scientific community.
Yeah.
Actually, I'd be very curious to know if there is a personality distinction between people who choose relatively new arms of science versus, the old. I'm just imagining Isaac Newton teaching some kids, like, all right, we got this new thing called gravity. Yeah, I want to study that.
Well, I want to answer that because I think it actually has some relevancy of gender equity in science. So what I've seen, which is interesting, is wherever there's something new, when it's like no one's quite doing it yet, women have more of the opportunity to kind of pop in and become the leaders. So you see this in exoplanet science right now, that exoplanet science is, while it was going on for a little bit of time where people were really searching, once it started to explode with like the Kepler spacecraft and all of the discoveries there's a lot of women that were involved on the ground and have built careers on this. And in brown dwarf science, we have a great collection of fantastic scientific, of women STEM scientists in brown dwarf science. And it was new and there was opportunity. I feel also really good that the people that were there didn't get selfish and saying like, it's mine, it's mine, it's mine. It was very welcoming. And it was an open. And so when you have new bits, a new subfield opens, it's also an opportunity to not have the old guard there that's protecting it all and deciding that you're not going to let everybody in that could be let in.
Right. And you're not fighting against the idea of, You don't look like a brown dwarf scientist because there's not some old etchings of, someone from ancient Greece with a giant beard and a robe.
Right. Right. You don't have that standard vision. So I might be what you think of when you think of a brown dwarf scientist now.
In fact, you are.
Oh, good. And Davey.
I'm wondering why Davey's hair is so short.
I've been cutting it myself during the pandemic, and I have no idea what I'm doing.
Hey, it's nice scientific precision all over there. All right, let's see if we have. Do we have another audience question? Yes, we have one from Tom Bickle. This is interesting. Could there be close-ish brown dwarfs that are too faint for WISE to detect? Do you want to take that one, Davey?
I can take that one. Yeah, sure. So the coldest brown dwarf we currently know is something called WISE 0855. And that one is only 250 degrees Kelvin, which means that if you translate that into Fahrenheit, it's about -10. So that's a cold object. It is only 2.3 parsecs away, which is something like 6 light years. And there must be lots more of those. I mean, why would the only very super, super cold brown dwarf be, just right in our backyard? But you can imagine something that's 200 Kelvin or 150 Kelvin, even colder than this thing. It could be sitting as close as Barnard's star or as close as Proxima Centauri. We wouldn't be able to see it at all, even with WISE. So yes, this is absolutely possible.
It's so fascinating, the fact that, because a lot of us are still in the ancient idea of studying the stars means walking outside and looking up with your eyes. But you guys are detecting and taking in information on so many other levels now. But apparently there are still limitations even to where we are now.
Well, I want to say something on that too, is that you walk outside and you think you're looking at all of the stars. But did you know that when you walk outside and you look up, and you say, okay, I'm going to look at the closest star to us. I want to see the closest star. You can't see it. It's too faint. The closest star is Proxima Centauri, and it's right at the limit of the human eye. So you're not even seeing the closest star. This is what should astound you about your view of the universe. While it's gorgeous, and I absolutely implore everyone to go outside, look at the nighttime sky, get awed of the wonder and all of the da-da-da-da-da, but then think about the mystery of what you're not seeing.
Yes.
And so that's like what Davey and I are into too, because there's so many of these little balls of gas that are out there, these brown dwarfs that have fascinating weather phenomena that may very well be closer than the closest star that you can't see because they're just so faint. And I'm certainly driven by that mystery, by the mystery of our own solar neighborhood. Like, what else is there? I'd love to know.
I love that. Oh, here's another question that I have for you guys. How can viewers join in on the brown dwarf hunt?
Yes, you can join right now. You can join by going to backyardworlds.org. That is that is the project. It's a Zooniverse project, meaning Zooniverse is this great portal which pulls together projects that bring citizens from anywhere and everywhere to participate. Like I was saying, dip your toe in the scientific research world. There's loads of projects to choose from on Zooniverse, but we are the one that I would tell you to choose. And come join us on our search for brown dwarfs. Backyardworlds.org. Check us out. It's a great project. And once a week, we have research, we have calls, and the citizen scientists join in. I would say it's really fun, right, Davey?
That's right. We have one on Thursday mornings our time, and also one on Saturday mornings for people who can't make during the week. And you sit around, you talk to your other colleagues on, your armchair astronomers, as well as some of the professional astronomers who join in as well. So I know people get a lot out of the fact that they hear the banter back and forth between the scientists, because they don't see science working in other aspects, because you just see press releases and things, but they get to see how the sausage is made.
Right. Oh, that sounds amazing. So yes, anybody out there who's got some time Thursday and Saturday mornings, you can help find out information about our universe at
And-
backyardworlds.org.
You know what? If we could show image number 5, I just want to highlight this is something that the citizen scientists also do. This is an artist rendering. One of our citizen scientists, his name is Billy Pendrell. I want to say he drew, painted on top of some other drawings. This rendering of that first video that we showed of those two objects bouncing back and forth. This is the discovery of a hotter object, which is the yellower object in the more distant, and not in the foreground, and this purplish object, which is the colder object, the brown dwarf. Right. And Billy drew it, and I love seeing this. Also, bring your talents outside of research to us. Artistic talent is underappreciated in the sciences. We would love to bring you into the research fold as well. Just like Billy, who now draws a lot of things for us. He's come up with a lot of really cool renderings.
Excellent. I love that. So we've got a volunteer fire department. We've got a volunteer astronomers. I love it. All right. Before we finish up and ask you guys for your final thoughts, I just have to say that, Jackie, when you were talking about the mystery of the universe and how brown dwarfs are an example of that, it really triggered something for me. It was so amazing because so many times you hear people talk about, astronomy, and looking up into the sky makes me feel insignificant. But the idea that looking up into the sky and thinking about what you're not seeing, this makes me want to go get a master's degree so I can find more stuff.
Yeah. Like, let the carrot be when you go outside and you see a really gorgeous nighttime sky, and then flip it and think, well, this is awesome. I mean, what am I missing from here? And what you're missing is a lot. Wow. Like, so much stuff out there.
Exactly. Well, I guess maybe but do you guys have any other final thoughts before we wrap up that you would like to share with our audience?
There's one other thing that I wanted to show, which I'm super proud of, and that is if you bring up image number 6. So what this is I worked with an artist whose name is Amanda Fingbody Hakia. It's a really hard last name to pronounce, but that's her sitting at the base of this mural. This is a mural that exists on a building wall in Brooklyn, and it is an homage to brown dwarfs. So the colors that you see, the reds and the blues, are supposed to reflect the two different kinds of brown dwarfs. The redder ones are these L types that have very cloudy, they have pretty thick clouds, and the blue colors are the lower temperature, what we call the T types, that are very methane gas dominated. And as I like to describe them, brown dwarfs are windows on the universe. And so you can see the windows opening. And it was also an homage to women in science, which I'm very proud of how it looks. I think she did an amazing job of depicting females as brown dwarfs, and it's called A Cluster of Enigmas. And I would just encourage anyone that wants to see it, that might be in Brooklyn, or maybe when we all get a chance to travel again, you might, take a little side trip. These are always fun little things that you can figure out that are in a city. But this mural that is it's at a medical center in Fort Greene, Brooklyn. You can go look at this and take it in and think about the brown dwarfs. Think about what brown dwarfs are, of what they might mean to you. They're certainly, to me, a gateway into science. They feel like sort of my family. My family members are now brown dwarfs, even though that also sounds a little weird, but just gonna go with it.
That's great. That's great. Davey, how about you? Final thoughts to share?
Well, we could actually show image 1. It'll give you a little indication of what our Thursdays look like when we have our group of citizen scientists get together. So these are really fun discussions. The scientists learn a lot from us. We actually learn a lot from the scientists. I look forward to these every week. And really, if people want to get involved, please get in touch with us via Backyard Worlds, and we'll put you in touch with the greater team. There's a lot of people out there who want to be looking through the sky, looking for new objects and making discoveries of their own. So please join the team.
Excellent. Thank you. Thank you, Dr. Jackie Faherty. Thank you, Dr. Davey Kirkpatrick, for sharing your expertise with us and introducing us to the intricacies and mystery of brown dwarfs. And thank you to you guys for joining us and learning about our sun's neighborhood. Now, you can see this video as well as all of our other Universe Unplugged videos at universeunplugged.org. You can just click on the link in the comments. You can subscribe on YouTube, and then you will be the first to know when our next video comes out. We try to do them once a month, but you never know. And also follow us on Facebook to catch the live show. And until that next live show, whenever it is, I'm Phil Lamar, and this has been Ask the Astronomers Live. Thank you guys very much.
Thanks, Bill. Thanks, Ethan.
Thank you.